Today we'll be finding the integral from 0 to infinity of x arctangent of x divided by x squared plus 1 squared dx. And we can make a substitution. We could let j equal x squared plus 1, which means that j minus 1 equals x squared, which also means that x equals the square root of j minus 1. And that dj over 2x equals dx. J sub 1 will be 1 and j sub 2 will be infinity. So j is from 1 to infinity. So we have the integral from 1 to infinity of x arctangent of the square root of j minus 1 divided by j squared times dj over 2x. And as you could see, the x's cancel. We could bring down the 1/2 integral from 1 to infinity of the arctangent of the square root of j minus 1 divided by j squared dj. And now from here we could use integration by parts. So we can let u equal to the arctangent of the square root of j minus 1, which means that du is 1 over 1 plus the square root of j minus 1 squared times the derivative of the square root of j minus 1, which is times 1 over 2 times the square root of j minus 1, which simplifies to 1 over 1 plus j minus 1 times 1 over 2 times the square root of j minus 1, and the 1's cancel, so we're left with du equals 1 over 2j times the square root of j minus 1, and dv equals 1 over j squared. So v equals the integral of 1 over j squared, which is negative 1 over j. So we'll have 1/2 arctangent of the square root of j minus 1 times negative 1 over j, evaluate it from 1 to infinity, minus the integral from 1 to infinity of minus 1 over j times 1 over 2j times the square root of j minus 1 dj. And as j approaches infinity and j approaches 1, this limit tends towards 0. So we have 1/2 negative the integral from 1 to infinity of minus 1 over j times 1 over 2j times square root of j minus 1 dj. And the negative and negative will make a positive. 1/2 the integral from 1 to infinity 1 over 2j squared times square root of j minus 1 dj. We could bring down the 1/2, so we have a 1/4 the integral from 1 to infinity of 1 over j squared times square root of j minus 1 dj. I'll clean up the board and we'll finish off this integral. So we just got done showing that the integral from 0 to infinity of x arctangent of x divided by x squared plus 1 squared dx is just 1/4 the integral from 1 to infinity of 1 over j squared times the square root of j minus 1 dj. And from here we can make another substitution. I'm going to let m equal the square root of j minus 1, which means that m squared equals j minus 1, which also means that j is m squared plus 1, which also means that dj over 2m equals dm, which also means that dj equals 2m dm, and that m sub 1 will be 0 and m sub 2 will equal infinity. So the bounds are from 0 to infinity. And so this is equal to the integral from 1/4 the integral from 0 to infinity of 1 over j m squared plus 1 quantity squared times the square root of j minus 1, but that's just m. And we said dj is 2m dm. And as you can see, the m's will cancel, and we have 2/4 the integral from 0 to infinity of 1 over m squared plus 1 squared dm. but 2/4 just simplifies to 1/2 the integral from 0 to infinity of 1 over m squared plus 1 squared dm. From here we could just make a trigonometric substitution. We can let m equal to the tangent of theta, so that dm is secant squared theta d theta, and that m squared plus 1 is tangent squared plus 1, which is secant squared. And we have m squared plus 1 squared, which is be secant squared times secant squared. So this, and if we solve for theta, we have the arctangent of m is theta, and at the bounds we have theta sub 1 is the arctangent of 0, which is 0, and theta sub 2. As m approaches infinity, this limit tends towards pi over 2. So theta ranges from the closed interval from 0 to pi over 2. So we have 1/2 the integral from 0 to pi over 2 of 1 over, we said m squared plus 1 squared is secant squared theta times secant squared theta, and the dm is secant squared theta d theta, and you can see one of the secant squares cancel, and 1 over secant squared is just cosine squared. So we have 1/2 the integral from 0 to pi over 2 of cosine squared theta d theta, and you could recall that cosine squared theta is 1/2 1 plus cosine 2 theta. So we have 1/2 the integral from 0 to pi over 2 of 1/2 times 1 plus cosine 2 theta d theta. We could bring down the 1/2, and we have 1/4 the integral from 0 to pi over 2 of 1 plus cosine 2 theta d theta. And this integral will be theta plus 1/2 sine 2 theta, evaluate at the endpoints 0 to pi over 2. So this will be 1/4 pi over 2 plus 1/2 sine of 2 times pi over 2. So this is the f of b term minus f of a. So you notice if you plug in 0, you have 0 plus 1/2 times the sine of 0, but that would just be 0. And as you can see, the 2's divide to 1, and we have 1/4 pi over 2 plus 1/2 the sine of pi, but we all know that the sine of pi is 0. So we're left with 1/4 times pi over 2, or in other words, pi over 8. So now we can say, therefore, the integral from 0 to infinity of x arctangent of x divided by x squared plus 1 squared dx evaluates to pi over 8. And this is the final result. Thank you very much for watching.